That's okay.
Recording in progress.
Okay, sorry, I meant to record that a little earlier. So anyway, here's number one. Again, x-intercepts, plug in 0 for y. X would equal -1 or -3 to make y equal to 0. Axisymmetry goes right through the middle. It's at -2. Once you have the axisymmetry, the vertex for the vertex also -2 because it's going to be on the axis symmetry. Plug in -2 in the equation, you get -3 for y. And then, of course, y-intercepts 9, we plug in 0 for x. So that was a little rapid fire compared to what I just said past few minutes. All right. Now, what form is this in? If you compare it correctly, it's totally a vertex form, right? But here's the thing. You could compare it, but maybe the more I think about it, maybe I did you guys a disservice by giving the formulas. Maybe I should not have given the formulas because it forced you to not memorize and understand. If you have x squared, actually, I probably should start with part A. I mean, part 2 probably should be in part A. I probably should start with that. Y equals x squared is easy. You guys know how that looks. That's super easy, right? Y equals x squared. So let me ask this question then. If I were to do x squared plus 9, how does that change y? What happens to the y values if I add 9 on the outside? Goes up 9, right? So total goes up 9. So obviously we're up 9. All right. If I do this, how does that change the graph? If I do -5 next to x. Yeah, because we got to put 5 for x, so this will be 0 for y, right? So it goes 5 right. So it's totally going 5 right. So guess what? You got your vertex done. You don't even need those formulas. I don't even show these formulas to my calculus, pre-calculus students because they know how this works, right? So maybe I shouldn't have given you guys formulas, perhaps. I don't know. So that way you guys don't get caught in memorizing. You use more logic, right? So 5, 9. Oops. Actually, I lied. If you have a +5, where's it going to be? To the left, sorry. So going a little too fast here. So let me slow down a little bit, catch my breath. It's just a fast class today. Left 5, my bad. Okay, so it's going to be left 5. So -5, 9. And of course, axisymmetry is on the vertex, right? So there you go. So let me plot that correctly. -5, 9, way up here. Sorry, kind of struggling. Okay, axisymmetry is like that. Now, I did say graph at least 5 points. If you did 3, it's fine. I think it's pretty obvious. Try -4 and -6, right? That seems pretty easy points to plug in. If you plug in -4, you should get 8. And if you plug in -6, you should also get 8. And they should be the same y values because of symmetry, right? We expect that. So there's your graph. Easy. And obviously it got flipped over too. They can't say flipped over. I say that just casually. You got to be more proper. I mean, up 9, left 5 makes sense. You have to say reflect about the x-axis. If you say flipped over, I have no idea what you mean. Do you mean flip over the y-axis? Flip over another axis? You got to be more specific and more formal with your language. This is part of the training that as you guys move on through Algebra 2, pre-calculus, and calculus, you got to be more sophisticated in the language you use. So we're going to, embrace that. So reflect about x-axis. Domains, obviously all real numbers. I don't think anyone really missed that. That was fine. All real numbers. And of course, the range is less than or equal to 9. Done. Didn't take me very long, right? Very simple. All right. Next one. Yeah, this is where I think we start running some issues. And again, I think part of it is also, I don't know what middle school experience you guys have, but some middle school experience were better than others. I think Zoom was probably to blame for that. Or not Zoom, but the remote class. So here's the deal. You got to look for common factors first, right? Is there something common between 15 and 60? 15. Higher than 5, go 15. But it's not complete, is it? Half of you guys did not complete this. Can I break this down even more? Yeah, x minus 2x plus. You have to recognize the difference of 2 squares. I don't drill this because it should have been drilled in 8th grade and 9th grade. But if you need help, I'll talk to you after class. I'll give you guys extra drilling, or Ms. Graham can provide that. But factoring is going to be a big deal. It's going to be something that's got to be fast. You got to move quick with it. I don't expect my calculus students, when I talk calculus, to think hard about it. They got to do it quickly. Now here, obviously nothing's common. So you could do a fact by trial and error if you wanted to. If you get good with it, you could do trial and error. But sometimes we do A times C and B. We do a little kind of a little crutch here. -20 and 19. So A is 4, C is -5, B is 19. And your goal is to find two numbers that multiply -20 add up to 19. What two numbers would do that? 20 and -1, right? Exactly. Thank you, Elizabeth. But you don't put x plus 20 and x minus 1, right? Because that wouldn't get you back to the original expression. That wouldn't make sense. What you do is you have to either do factor by grouping, or you can do a little box. Some of you guys like the box idea. So you put 4x squared and -5. And what the 20 and -1 did, what that does, it actually splits this into two. So 20x and -x, and that's a -5. That looks really ugly. And then you factor along each row in each column, right? So you get x, 5, 4x, and -1. So there you go, done. Very simple. Okay, now we get to the problems where things really, where the wheels fell off. Okay, if you're getting vertex form, please start vertex form. Don't start with standard form. It makes no sense. If you start with standard form, you're going to be spinning your wheels, right? Actually, there will be no wheels. The wheels fell off. You got nothing. you're just friction on the ground and sparks, and it's crazy, right? You got to start with vertex form because I gave that to you, right? That's just using logic. I mean, why would you start with anything else? So y equals a, x minus 1 squared plus 6. Done. I'm halfway done. In 2 seconds, halfway done. You have another point. How can I use that to help me?
Insert part A.
Yeah, because what's the whole point of an equation? An equation is a relationship between variables, right? That's all it ever is. Like for example, what if I want to make an equation to compare like your heights and weights? Like what if I ask someone, write down your heights, write down your weights, and plot all the points and try to make those that split line, right? I mean, that's a relationship. I'm trying to relate height and weight. Or what if I like to tell me how many hours you sleep in your GPA? I mean, that'd be kind of weird. But I'm trying to make an equation, trying to make a relationship. That's all that's happening here. I'm trying to make a relationship. You're told a point that fits that relationship. If it fits that relationship, by God, use it. Plug a 9 and 4. That's it. And that should be really easy. You get 9a plus 6 equals 9. 9a equals 3. A equals 1/3. I gave majority of the points toward that process because that was kind of the big part of the problem. Now you got your equation, but you're not done yet. What I'm asking you to do after that, to put it in standard form. And the reason I asked that, I want you guys to practice FOILing, right? And combining like terms. It's not hard. That's just x squared minus 2x plus 1. You guys have done it many, many times. I know you guys have. Distribute, combine like terms. So you get 1/3 x squared minus 2/3 x plus 1/3 plus 6, which is plus 19/3. You could leave that as a improper fraction, or 6 1/3. If you want to do a mixed number, I don't care. Or 6.33. If you want to do decimal, that's fine too. But that's number 4. And now I got a huge sigh here. This is the part where I got a little bit worked up with you guys. Okay, we did this. We did this in the review. It was there. And when I did this, I didn't do that much work. Like we knew that this meant the maximum heights of vertex. We knew that, right? Or here, we knew that how far it travels, that's an x-intercept. We know that. And I even shared the solutions with you guys too. There we go. And it's not terribly much work. I mean, part A, because it's evaluating, but look at part B. That's just 2 steps. Maybe switch, plug in that, right? And then C, just plug in that number, done. Not that hard. And it wasn't worth that many points. Right here, you know, you have yes, intercept, or you have a vertex in part A, but you could double it, or just if you have intercept 69.9, done. That's all you had to do. However, I saw a crazy amount of work, and I think what happened was when you got to this point, you guys were spending about 10 minutes on this when it's only worth 6 points. How many points is the test worth? 60. Okay, let's do the math here. 6 out of 60, that's 10%. You have 50 minutes, right? If you're spending 10 minutes on this, what does that reduce to? 1/5 or 20%. Does that make sense? Spend 20% of the time on 20% of the points? Absolutely not. That is, you shot yourself in the foot. Please don't do that. If it doesn't come to you right away, and I get it. You guys freeze up, totally get it. But you guys got to be better test takers than that. You got to move on and come back to it later, or just say screw it. I'll lose those 6 points and get a 90% on this test, right? It's not worth it. And then, of course, you didn't finish the test, right? And you got flustered. So, yeah. So first of all, don't do that. Don't spend too much time. And it's 3 points. So the answer, it's easy. 8. Done. And if you just said y corner vertex, congratulations, you get full credit. Takes like 10 seconds. Here, 5.74, done. X-intercept, because that's what's supposed to happen, right? You jump, you land. So there you go. That's it. That's all I had to do. So that's number 5. I don't have to say more on that, but don't do too much work. That was crazy. All right, number 6. Let's deal with that one. Okay. Well, are you giving the x-intercepts? Yeah, totally. So let's use intercept 4. Y equals a, x minus 2, x minus 5. And are you giving another point you can use? Sorry, thanks, Alex. Yeah, 4 equals a, -1 plus 2 times -1 minus 5. 4 equals -6a, a is -2/3. And then there you go, you got your equation. Again, does not take very long. But if you got flustered with the previous problem, you can't think straight, and the time's ticking. Yeah, of course you're gonna make mistakes because you're you're getting anxious. You're human. I get that. But if we're efficient or use good test strategy and don't waste too much time on the previous problem, or realize it's not that hard, just extracting the information from the equation, you've been fine here. X squared minus 3x minus 10. Distribute -2/3 x squared plus 2x plus 20/3. Yeah, there you go. Done. Okay, now I will admit I probably could have worded this one better. And I did try to offer clarification, give it extra time to fix this, which is why we're doing a retake. Don't worry. And maybe I just assumed, maybe because like Aaron Brothers closed on Redwood City 5 years ago, people don't frame stuff anymore. It's a border around. The mat is a border. It's not a doormat. The mat is basically the border around. So it's a cut. There's a cutout in the middle. Think of it that way. There's a cutout in the middle. So this is 300 right here, the picture, and this is 300, the white part. So overall, the area is 600. Overall, the dimensions are 4x plus 20. If you go 2x, 2x, and 20 in the middle. And of course, 2x plus 15. So I could probably word this better. I will definitely take fault for that. But I tried my best to help you guys out if you're in the room. If you're in ASC, don't worry, you get a retake opportunity. So you'll be fine. And then you just got to solve it, which I know you guys can do. You just have to FOIL, which I'll do really quickly. 100x plus 300. 0 equals 8x squared plus 100x minus 300. You have a calculator. You can factor out a 4, I think. Is that right? Yeah, 2x squared plus 25x minus 75. If you factor correctly, you should get 2x minus 5 and x plus 15, I think. Yeah. Can't be negative for x. That would make no sense. So it's 2.5. Once you get 2.5, you can get the dimensions, which would be 30 inches by 20 inches. If you plug in 2.5 for x. So that's all for that one. And then lastly, these two guys. I think this is fine. I think, again, if you're running short on time, maybe you got a little anxious, but 48, move that over, divide the 3. Okay, what's square of 16, guys? Some of you guys left it at 16 though. And you got to put plus or minus. Some of you guys forgot that too. So you should get 2 plus or minus 4. So 6 or -2. Here, I would actually reduce this first as 4/5. Then write as 2 over root 5. And then multiply top and bottom by root 5. Done. Much easier if you reduce first. And lastly, for B, yeah, you got to do minus root 3. And that the reason why you have to do that is so the radical goes away, because that's the whole point. You don't want radicals in the bottom. So you get 8 minus 2 root 3. And if you follow the bottom correctly, you should get 13 on the bottom, if you do it correctly. So there's a test. And I just record this. I'll upload the recording to YouTube so you have access to it if you want to watch it. Now, the schedule. Let's talk about the schedule for a while. Our next test, and you guys can keep this. Our next test is not until sorry, it's Halloween. Halloween day though, not the day after Halloween. So Halloween day. I'm sure there's gonna be parties for the weekend. I get it. But the plan is the retake will be given probably the week after that, by week November 7th is my guess. So if I pull up a calendar here, yeah, let's go to November. So my guess is probably that week. Right? And just the teachers from this class, not the only teachers. So not this group, not the only one. And we write tests. We always have a collaborative effort. So I write tests with Mr. Davidson and Mr. Gilmore and Ms. Bennett. So those three people get together, they'll put together a good retake. I might actually help design it before this Friday, just so they have a draft and they can use it if they want to. But my guess is it's probably going to be one that'll be good, or maybe the week after and get Thanksgiving back. So, and it's much better to do it after a while to give you guys enough time to kind of let this sink in. Because guess what? We're not leaving chapter 4. You're going to do more chapter 4 over the next few weeks. So this will just get reinforced. And maybe when you look at it again, like, oh my God, how did I miss this? Like, I totally, yeah, it totally makes sense now, right? A lot of times that happens with math, right? And let me stop recording.